By the end of the course, you'll have an excellent grounding in the fundamentals of sports analytics. My name is Steve, and I'll be your instructor for the course. I'm an expert in data, AI, and sports, and have 20+ years of experience. My goal in this course is to pack that 20 years into a few hours of course time. Note that for our online courses, while I create the content and hands-on demos, I work with a professional voiceover team when we produce and publish to the web. You may also see different learning avatars along the way. They'll provide different tips and tricks, best practices, and additional resources for you to use. Jake is our sports scientist, Amy is our data analyst, and Megan is our data scientist. Welcome to the 7th module in the Introduction to Sports Analytics course. The learning objectives for this module are as follows. Understand key concepts behind analyzing team, player, and game performance in sports. Identify commonly used metrics for evaluating teams, players, and games. Learn how to apply data analysis techniques to answer questions about team and player performance. Conduct a basic analysis of a team, player, or game using a sample dataset. To achieve these learning objectives, the content will include the following themes: characteristics of team, player, and game performance analyses. Types of data needed for the performance analyses. Creating an analysis. Team, player, and game performance analysis is one of the most foundational aspects of sports analytics. In this module, we'll explore what performance analysis is, why it matters, how it differs across teams, players, and games, and how sports teams use these insights to gain a competitive edge. The first couple of questions we'll explore are, what is sports performance analysis, and why is it important? Sports performance analysis involves collecting, interpreting, and applying data to evaluate and improve performance in sports. It spans multiple layers, from how a team executes its strategy to how a player performs under pressure during critical moments in a game. You'll find that through this idea of layering, there's a red thread that you can draw from game time performance to player performance to team performance. That is, events in a game such as passes and goals give you a picture at the game level, who passes and scores those goals gives you a picture at the player level, and how the team passes to one another and how lines operate gives you a picture at the team level. Sports performance analysis is important for a few reasons, such as the following. Teams use performance analysis to identify strengths, weaknesses, and opportunities, enabling them to outperform opponents. Coaches and analysts use data-driven insights to make informed decisions, whether it's optimizing player rotations, choosing strategies, or scouting opponents. Player workload and biomechanics data help reduce injury risk and accelerate recovery times. Leagues and broadcasters use performance analytics to create engaging content for fans, from advanced stats overlays to storytelling. Think of performance analysis as the blueprint that turns raw talent and effort into measurable, strategic excellence. While performance analysis applies to all aspects of sports, the focus and methods differ depending on whether you're analyzing teams, players, or games. Team performance analysis focuses on collective performance metrics like ball possession, offensive and defensive efficiency, and shot quality. A practical example might be expected goals, XG, in soccer or hockey, and adjusted offensive ratings in basketball. These metrics can then be used to analyze the performance of a team, such as evaluating expected goals versus actual goals. Player performance analysis concentrates on individual performance and their contribution to the team's success. For example, player efficiency rating, PER, zone coverage in hockey, or passing accuracy in soccer. Game performance analysis examines contextual, in-game events and outcomes to understand specific match dynamics, win probability, live or historical, clutch performance, or lineup matchups. For example, analyzing the last 5 minutes of a tied game to understand decision-making under pressure. Performance analysis isn't just theory. It's used daily by teams, leagues, and analysts to gain an edge. At the team level, you might leverage performance insights for tactical adjustments. For example, analyze opponent tendencies to create game plans, such as the professional basketball teams using heat maps to adjust defensive spacing against top shooters. You can also use them in player development, such as NHL teams tracking skating efficiency to refine player training regimens. At the league level, you might leverage performance insights for broadcast enhancements. Leagues like the NFL use advanced stats, for example, next-gen stats, to enhance game broadcasts with real-time insights. You might also use them for scheduling. For example, the MLB uses analytics to create balanced schedules and optimize travel for teams. And finally, analysts use performance insights for scouting and recruitment. For example, analysts use data to evaluate trade targets or draft picks, identifying hidden gems based on metrics like XWAR, wins above replacement. And from a post-game analysis perspective, hockey analysts break down power play efficiency to determine why certain teams excel in man-advantage situations. For example, in hockey, you can determine how well the team converts man-advantage situations into goals through power play efficiency reports. Further, you can measure how effectively the team moves the puck out of the defensive zone and into the offensive zone, using zone exits and entries analyses. In soccer, you can track the percentage of time a team controls the ball during a game using possession metrics reports. You can also analyze how quickly and efficiently a team regains possession after losing it through pressing effectiveness reports. And in basketball, you can measure points scored per 100 possessions to evaluate scoring effectiveness using offensive efficiency reports.
In this first demo, we're going to create an example win-loss ratio report. The report will compare two teams against the league average. We'll use the R programming language to create the report. Let's start by jumping into RStudio, the development environment for the R programming language. We'll first load the tidyverse package and then load an external dataset into a data frame. The dataset has a ton of statistics in it. You can see the dataset here, which spans 107 years of NHL hockey statistics. This dataset is then used by the R application to create a filtered data frame comprising season, team, wins, losses, and points. We'll use this filtered dataset to calculate the win-loss ratio. The code also saves the resulting data as an external file, which you can see here. We've included all of the teams but filtered the file for 3 seasons. We'll now create a data frame to compare two teams, Florida and Colorado, and then plot the two teams using a bar chart with the league average included as well.
Unlike team analysis, the player performance analysis zooms in on individual players to evaluate their contributions, skills, and areas for improvement. This type of analysis is useful for player development, scouting, and making strategic decisions about roster management. So, what is player performance analysis? Player performance analysis involves evaluating an athlete's performance to identify their strengths, weaknesses, and overall impact on the game. The goals of player performance analysis are as follows: to assess how well a player is performing in different areas and contributing to team objectives, to provide targeted feedback for skill development, to inform decisions related to lineups, trades, or signings. The types of questions addressed through a player performance analysis are as follows: how effective is a player in their specific role? For example, scorer, playmaker, defender, etc. Are there trends, either positive or negative, in performance over time? How does the player perform under different conditions? For example, home versus away, against stronger opponents, etc. Here are some ways player performance is analyzed in hockey, soccer, and basketball. For hockey, you can analyze goals, assists, and point production to evaluate scoring impact to understand offensive contributions. You can measure blocked shots, takeaways, and zone clearances to evaluate defensive reliability. And you can analyze metrics like Corsi or Fenwick relative to the player's time on ice to measure impact on puck possession. For soccer, you can evaluate the percentage of successful passes in different areas of the field using passing precision. You can also measure tackles, interceptions, and clearances through defensive actions. And you can analyze the player's conversion rate for shots on target with goal-scoring efficiency. For basketball, you can determine field goal percentage, FG percent, three-point percentage, 3P percent, and free throw percentage, FT percent, using shooting accuracy. And you can evaluate assists per game and turnover rates with playmaking reports.
In this second demo, we're going to create an example, player performance report. The report will find the top 10 centers by 2-point attempt percent. We'll use the R programming language to create the report. Let's jump back into RStudio, the development environment for the R programming language. We'll first load the tidyverse and tidyr packages, and then load an external dataset into a data frame. The dataset has player statistics from the 2024 to 2025 season. You can see the dataset here, which includes a host of statistics for each player. This dataset is then used by the R application to create a filtered data frame by a player's position. We're specifically interested in centers. We'll use this filtered dataset to create an even smaller data frame that only includes the top 10 players. The code also saves the resulting data as an external file, which you can see here. We can now use the external Excel file to create a table and a column chart to compare the top 10 players. If you wanted, you could also do this in R.
Game performance analyses evaluate an entire game as a single entity, analyzing patterns, momentum shifts, and strategies. The goal is to understand how the team and its players performed in a specific matchup, and to identify opportunities for improvement in future games. Game performance analysis examines the collective events, decisions, and outcomes of a single game to uncover the factors contributing to success or failure. The purpose of a game performance analysis is to evaluate team performance dynamics in the context of a single game, to analyze how game conditions, for example, opponent tactics, venue, crowd, and so on, influenced outcomes. Some of the questions that a game performance analysis addresses are: what strategies worked or failed during the game? How did momentum shifts impact the outcome? Were there key plays or sequences that decided the game? Here are some ways game performance is analyzed across hockey, soccer, and basketball. For hockey, you can track successful offensive zone entries and how they led to scoring chances with a zone entry analysis. You can compare shot locations and danger levels between teams through shot quality assessments. For soccer, you can break down how possession was distributed between teams and its impact on game control with a possession analysis. You might evaluate outcomes of free kicks, corners, and penalties through set-piece effectiveness. For basketball, you can identify stretches where teams scored consecutively to swing momentum using scoring runs. And you can measure how well the defense forced poor shots or turnovers through a defensive efficiency report.
In this final demo, we're going to create an example game performance report. The report will find the events that occur the most in a game and the types of shots that are most associated with goals. Here's the dataset for a single game. It's a big file with a ton of data in it, each row representing a unique event in the game. We'll use the R programming language to create the report. We'll first load the tidyverse package and then load the external dataset into a data frame. The dataset has event statistics and metadata from a single game between Chicago and Philadelphia. This dataset is then used by the R application to create a filtered data frame, as we're only interested in a subset of the data. We'll use this filtered dataset to create an even smaller data frame that only includes the unique events in the game. The math is pretty simple here. We take the total of each of the events and then we plot them. Now, this is pretty interesting because it shows you generally what happens within a professional hockey game. However, we're interested in what shots result in a goal. So we filter the data for goal and then see what unique events, which are the shot types, precede the goal. And here's the final chart in R.
Across these three different types of performance analyses, there are foundational techniques that every sports analyst needs in their toolkit. These methods help you summarize, visualize, and compare performance data to extract meaningful insights. The first approach is to use descriptive statistics to summarize performance. Descriptive statistics are numerical measures that summarize and describe the data. Examples include averages, medians, standard deviations, and percentiles. Descriptive statistics provide a quick way to understand the central tendencies and variability in performance data. Another technique is to visualize trends and patterns. Visualizations help us identify trends and patterns in performance that aren't immediately obvious from raw data. Visualizing data allows us to reveal trends, for example, performance improving or declining over time, and to highlight patterns, for example, a player consistently performing better at home games. You might leverage visualizations to create a line chart showing a player's goals per game across the season in hockey, a heat map of a player's pass locations on the field in soccer, a shot chart displaying shot locations and success rates in basketball. The specific types of tools you might use are Excel, Power BI, or Tableau, which are quick and intuitive tools for creating charts and graphs. You might also use Python or R, which are programming languages used for advanced, customizable visualizations.